Let's talk now about ranking groups of data. To illustrate what that means, we've set a group of numbers here between 2 and 25. There's 5 numbers. And what ranking amounts to is simply this. The lowest ranked number is given a ranking of 1. The second ranked number, the second highest value, is given a ranking of 2. The third highest value is given a ranking of 3. The fourth highest value is given a ranking of 4. And the fifth highest value is given a ranking of 5. So that's what ranking amounts to. Now above we created this sort series 2. Let's output it here so we can see the values. And the lowest value here is 2. And the highest value is 12. And it looks like we have 6 numbers. So we should see that reflected when we run this .rank method. So the 12 was index 4, and it's the highest of 6 numbers. So it was given a ranking of 6. The 2 was index 0, and it was the lowest of the numbers, so it was given a ranking of 2. But this 7 appeared twice, and it might at first be confusing how Pandas has handled this. These would have been the 4th and 5th ranked values between the 3 and the 6. So what Pandas did is simply took the average between 3 and 6 and applied that average to both of these numbers. Now we can override that behavior, perhaps by setting this to first. Let's run this. And what that did is it took the first number here, it took the first instance of 7, and it set that to a 4th rank, and it took the second instance of 7 and set that to a 5th rank. So we overrode this default ranking behavior. Let me remove this second parameter for a moment and run this. What Pandas has done here is it's reversed the order. The lowest number has now been given the highest ranking, and the highest number, 12, has now been given the lowest ranking. And because this has been reordered, Pandas has now taken the values between 1 and 4 and averaged between those to give this redundant 7 a ranking of 2.5. Now we can override this in other ways. We could tell it to take the maximum between 2 and 3. Run that, and it gives it the 3. We could also tell it to give it the minimum between 2 and 3. And that will give this redundant 7 a 2. We can compute rank over rows or columns here, and obviously we're going to need a data frame for that. So let's initiate one in which the indices here are out of rank. Now as usual in Pandas, ranking is going to rank along the index by default. So row-wise, under the B column, the 3 is the lowest ranking number, which has been given a 1, and the 7 is the highest ranking number, which has been given a 4, out of 4 numbers. Interestingly, in column A, we have 2 zeros and 2 1s. Out of what would normally be 4 rankings, it's given both zeros a ranking of 1.5, and it's given both 1s a ranking of 3.5. And column C behaves as expected. If we'd like to rank across the axes rather than down the rows, we can use this familiar axis equals 1 argument. And now if we inspect this, we can see that negative 2 is the lowest number, which has been given a 1 ranking, and 4 is the highest number, which has been given a 3 ranking out of 3 values.